In this series, we are going to look at velocity ratio. Now, velocity ratio is the ratio of effort distance over distance moved by load, or load distance. So it is often represented as effort distance over load distance, and the unit for velocity ratio is velocity ratio has no unit. Effort distance in meters, load distance also in meters. They are going to cancel out, so velocity ratio has no unit. So let's begin right away with the question above. A machine moves a load 5 meters with an effort of 10 meters. The machine moves a load 5 meters with an effort 10 meters. So this is the effort distance. So equals 10 meters over 5 meters, which is the load distance. So 5 here 1, 5 here 2. So you're going to have 2. That's your velocity ratio. The velocity ratio of a machine is 5, and the effort distance is 10 meters. Calculate the load distance. So we are saying velocity ratio equals effort distance over load distance. So the velocity ratio is 5 equals effort distance of 10 over load distance, which we don't know. So it's going to be load distance equals 10 on 5. So anytime you're doing change of subject, and then you have your denominator to be whatever you are looking for. If you have an equal to sign, you can just exchange these two, and it always works. So your load distance is 5 here 1, 5 here 2, 2 meters. Now take note, we are dealing with distance here, load distance, so it's 2 meters. The velocity ratio was 5, which had no unit. Now in the second part of this series, we are looking at mechanical advantage. Mechanical advantage is the ratio of load to effort. So in the question we have, a machine lifts a load of 100 Newton using an effort of 20 Newton. Find its mechanical advantage. Now before we start, kindly take note that the load will be in Newton, effort will be in Newton. So mechanical advantage also has no units. So the load is 100 Newton and the effort is 20 Newton. So Newton cancels Newton. 20 here 1, 20 here 5. So our mechanical advantage is 5. Kindly pause the video and then try this question. So if a machine has mechanical advantage of 3 and requires 50 Newton effort, calculate its load. So the mechanical advantage is 3 and the effort is 50 Newton. What is the load? We know that mechanical advantage equals load over effort. So the mechanical advantage is 3. The load is what we don't know. And the effort is 50. Now with this you can just cross multiply. So you are going to have load equals 3 times 50. So load equals 150 Newton. As we continue with this series, we are going to look at efficiency as well. Formulas for efficiency. You can have efficiency equals work output over work input multiplied by 100. We can also have mechanical advantage over velocity ratio times 100. So you are supposed to take note of all these. Now to the question. A machine has work input of 250 joule and work output of 200 joule. Calculate its efficiency. So we are going with the first formula. So the work output is 200 over the input, which is 250, multiplied by 100. Now always take note that your input will always be higher than your output. Why? Because some of the energy is wasted. That is why the efficiency of a machine can never be greater than 100%, or in terms of decimal can never be greater than 1. Alright, so to work this out, 10 cancels this, 25, 10 here, 10. So also 5 here, 5, 5 here, 2. So 2 times 200 is giving us 400. 400 divided by 5. So we are getting 80. So 80%. So efficiency is measured in percentage. Now pause this video and then try this. If the efficiency of a machine is 90%, calculate, so efficiency is 90%. Calculate the work input to reproduce 450 joule work output. So what input are you going to exert to get 450 joule? So we go by the formula, efficiency equals work output over work input times 100. So our efficiency is 90. 90 equals, the work output is 450. Let's represent work input with x, over x times 100. So to work it out, you have 90 equals 45,000 over x. So to make x a subject, let's exchange the positions. 45,000 over 90. So we are going to have 500 joules, which represents the work input.